Red Nieto Ramirez, ID A01286100. Hello, in today's video, I'll explore how I design, configure, and secure a scalable enterprise network interconnecting offices and automated production centers across different cities in Mexico. This network is not just about connectivity, it's built for security, automation, precision agriculture, wireless mobility, remote control of sensors, and long term scalability. To fully understand the architecture, I'll walk you through five major sections: the physical network design, the logical network design, the VLAN, DHCP, and OSPF implementation, NAT and MPLS integration, and the implementation of security schemes. We will start with the foundation, okay? The physical design. The network physical design, interconnection of offices and production centers. We should think of this as a section as laying out highways, roads, and bridges before we install traffic lights, signs, or security checkpoints. We will start with topology and its overview, the hub and spoke design. Like the organization operates with a headquarters, which is Ciudad de Mexico, as the central hub. All regional offices being Guadalajara, Monterrey, Querétaro, and León, and also the production centers connect back to the CDMX using a private MPLS cloud, simulating real WAN environments. Production centers are linked to their nearest office using point-to-point 30 subnets, minimizing IP wastage and simplifying routing. Let's go with the physical equipment per site, okay? The headquarters, the HQ, are the border routers, the SAA firewall, the core distribution switches, data center servers, and the wireless LAN controllers. The regional office are the border router, the layer 2-3 switch, and access points, and DHCP server router. Now for the production centers, there's router with multiple gigabit interfaces, the industrial switches, the firewall, IoT sensors, and barcode printers. For the WAN and MPLS physical links, we will use this. Well, I used the serial links DC to DTE for one simulation in the packet tracer, and the Ethernet links for MPLS simulation, and also slash 30 subnet links for point-to-point links, with IP being an example 172.31.255 and then the number you want. An example, okay, we are going to Saltillo to Monterrey. We will name our host name RTR underscore PL underscore Sal with the port gigabit 000 with the IP 172.31.255.1 slash 30. And then to Monterrey, we do the same as Sal, but now with the IP 172.31.255.2 slash 30. This creates reachability between sites without consuming large subnets. Uh, let's move on to the structure layer design at HQ. According to the diagram of the situation problem, the purple zone is the edge and security, which is the ICP, MPLS, and firewall. The red zone is the server farm, the ERP, DHCP, DB, and sensor management. We also got a zone for the employee access and another zone for the production and sensor equipment. Breaking the network into these various zones, I had it as colors like I mentioned, but I changed it to just separating them between their own clouds per se, to help us physically isolate areas with different risk levels, like separating the HR offices from IoT farm sensors. Then let's move to the wireless integration. Each office and production center includes various access points which help support mobility, the VLAN tag over wired trunk links, the centralized or local DHCP support, and can then be extended for future IoT and guest Wi-Fi. Now let's finish this part with the growth and redundancy considerations. It should be fiber ready based on real world scaling, spare interfaces reserved, extra 60 IP blocks per location, and a standardized equipment templates. So that now that all the cables are connected and devices placed, we will add intelligence through the logical segmentation, which is our next segment. We now move to the second segment, the logical network design, subnetting, addressing, and routing planning. The logical design is like defining postal codes, like districts and so on, so we can know exactly how to deliver the information we have. I first implemented an IP addressing strategy, which is each location gets a /60 master block offering up to 65K addresses for future proofing for expansion. The locations we used were HQ, GDL, Monterrey, and Saltillo plant, and the assigned blocks for each /60 block for HQ is 10.1.0.0. For Guadalajara, which is GDL, is 10.2.0.0. For Monterrey, it's 10.40.0.0, and Saltillo plant is 10.6.0.0. Then subnets are divided using BLSM based on the required hosts. Employees are /2423, the servers and voice are /26, as well as printers and IoT, Internet of Things. The management is /28, the environmental sensors and the ground sensors are /25. Now, for the standard VLAN structure across sites, here's how they are divided. This is important. The VLAN ID, we will start with VLAN 10, the purpose of it being the employee's LAN. The VLAN 20 is the purpose of voice IP. The VLAN 30 is the guest Wi-Fi, which is HQ only. The VLAN 14 is for IoT and printers. The VLAN 15 is for all the servers. VLAN 19 is for the admin or management. And VLAN 300 is for the sensor networks in production. The consistent VLANs IDs across all locations allow using templated configurations and easier troubleshooting. Now let's move to the routing strategy. For the routing protocol, we first use OSPF, which is for the internal LAN routing. We use EIGRP, which is for the MPLS1 routing. Static routes for point-to-point sensor connections, and redistribution for the border routers. The OSPF is used internally due to BLSM support, fast convergence, and the area design, which is the area zero backbone. EIGRP is used across MPLS for the performance and reliability, the better summarization as well, and which is also a requirement for our my problem solution. The lookback interfaces is pretty simple. Lookback 0 is used for OSPF and EIGRP router ID, which I use the command interface loopback 0 with the IP address 10.1.255.254, 255.255.255, and .255 pretty much. Now let's finish up this segment with the address where I will address the consistency rules, which are pretty important to follow or it won't work. The first usable IP is the gateway, and the last usable IP is the monitoring. This is pretty important. For the static IPs, we have the server, printers, and sensors. And lastly, for DHCP, is the employees and Wi-Fi clients. Now that you have reached this segment with me, we now have a structured digital blueprint. Now, let's move to the third segment of the video, which will help us configure the network to actually make it functional, which is what we pretty much want. Now we are in the segment 3, the VLAN, DHCP, and OSPF configuration. This is where cables and the IP plans finally come to life, where we tell the network how to behave. It's important to follow these instructions pretty well because this is where we use mostly the CLI configuration on our packet tracer. We will first implement the VLAN, which the trunk links carry multiple VLANs while access links carry only one. A quick example for the trunk on L3 switch, we do interface gigabit internet 0/1 with switch port trunk encapsulation .1q. The switch port mode will be trunk, and the switch port trunk allowed VLAN 10, 20, 14, 15, and 99, which are the VLANs I mentioned before. For the access port, we do the command interface fast Ethernet 0/12 with switch port mode access. The switch port access will be VLAN 10. Now, for a router on a stick for inter-VLAN routing, we do interface gigabit internet 0/0/0.20, and the encapsulation is for .1q20, which I stated before, with the IP address of 172.60.2.129, and we do the usual 255.255.255, but at the final dot we will add 192. This is really important. For the DHCP configuration, well, first per VLAN pool, we do the command IP DHCP pool employee CDMX. The network we do 172.60.00, yeah, and 255.255.254.0. And for default router, we can do the command with the IP 172.16.0.1. We are pretty much configuring here, like I mentioned, the DHCP, and it's pretty important that we state for which part it is, where we state it's for employees, the correct IP, the default router, and for the DNS server, it's important they all have the same. I always do 8.8.8.8 because it's simple to remember and pretty easy to use. And it's also important to exclude the static IPs, that being the IP DHCP, which excluded address is 172.16.0.1, and we follow with 172.16.0.20. Now let's move to the final part, which is the OSPF configuration, which is personally my favorite part and the one that's also really important like the others. Well, this one is really, really important. We do router OSPF 1. With the network, we put the IP 172.16.0.0, and we do 0.0.3.255 in area 0. Too many zeros there. And then for passive interface, we do gigabit Ethernet 0/0/0. Um, Take notice that this is my own configuration in the packet tracer, which is the solution for the situation problem. Everyone could have different IPs and they can use the same instructions as I did, but I follow the ones that were asked in the problem situation. Now the network can communicate inside, which is what we want, and our router actually works. Now let's open it to other sites and do the public internet carefully, which means let's move to the next segment. We are now on the fourth segment, which is NAT and MPLS integration. We will now unlock connectivity between cities and to the internet using MPLS and NAT. Let's see how to do it, all right? So the MPLS connectivity using EIGRP is configured only on routers with the MPLS links. We do the commands router EIGRP 100 with the network 192.168.0.0. For the for the NAT configuration, we have as a feature the static NAT, the HQ being on all the servers with only key servers on the offices. And for plants, it's rare use pretty much. For the feature dynamic NAT, it's used as the HQ, the employees, and IoT, which also uses offices and plants. And finally, the path overload, the HQ is the HQ with that also uses offices and plants. Pretty much yeses on everything. As an example for static NAT, which we use on Ciudad de Mexico, we have IP NAT inside the source static 172.16.3.10 and 152.78.211.10. For a dynamic NAT sample, we have as the IP, we put IP NAT pool, Monterey underscore pool or MTY. And this is a long IP, but stay with me because it's multiple for the dynamic NAT. We do 201.23.15.194, then 201.23.15, and then .222. And for net mask, we add 255.255.255. And 224. For IP NAT inside source, we will list one pool, which is the Monterey pool overload. These two types of examples are important to mention because, like it says in the name, one is static and one is the dynamic. And this pretty much lets us unlock the connectivity between the cities, which are based on the NAT configurations I mentioned previously. To finish off, let me mention the interface tagging, which it's important to stay which interface. I had so many issues with this part because I was doing it on the wrong interface. So it's important to mention. For example, we will use the interface HIG, that's how it says, 0/0/0 with the IP NAT inside. And then we will do interface serial 0/1/0 for the IP NAT outside. It's like I mentioned multiple times, the interfacing is important so you can avoid making the same mistakes I did of oh no, I'm having errors and I don't know why the interface. Always make sure to check that you're doing the correct interface and it's not actually HIG 0/0/1 or maybe if it's outside, then zero/0/1. Like you gotta make sure it's the correct numbers and in the correct ports, pretty much. Oh yeah, now that we finished this segment, let's now move to our final segment, the important one, in my opinion, as well, because it's the implementation of security schemes. You did it. You have managed to reach the final segment with me. The segment 5, implementation of security schemes. Now that everything is connected, we now have to protect everything, or else we are gonna get attacked, and that's what we're gonna wanna try about. So the security applied across layers. We have 4 layers in total. The first layer is the L3 or the one. The technology being the ACLs, the NAT control, and the firewall rules. For the access layer, we have port security, VLAN segmentation, and the SSH banner warnings, and password encryption. And the layer of monitoring, we have the NetFlow, Syslog, and SNMP. For an example, let's create the firewall of Ciudad de Mexico, all right? We start with the IP access list extended to SEC_CDMX. This is the part where we start permitting or denying IPs. It is important that before we do the any IPs allowed, we have to be specific from the beginning. Like, do not start with any or it won't work. The order is first be specific and then the any. What do I mean by this? Pretty much, we start with permit TCP any host 152.78.211.10 EQ www. Then we do the same with a different IP being 152.78.211.11 and then EQ www. Then we state the IPs we wish to deny by doing deny IP any and the host, which we will do IP 152.78.211.10. We will do also the same, but with the IP 152.78.211.211. Then now we do the permit ICMP any, and we establish it. That's pretty much the order you must go when adding your security with denying IPs or denying them. Yeah, pretty much. We will now do the part where we enable SSH and we block telnet as well. We do as the command transport input SSH with the service password encryption with the username admin privilege 50 secret, and then on the triangle you add 2 triangles and put in the middle hash. And then we will monitor this with NetFlow by doing the commands ipflow export the version 9. As an example, obviously, you can use any version depending on yours. And ipflow export destination. We will do IP 192.168.1.100 with 9996. So for the final security layer, which is physical, you just log the equipment rooms, port disabled by default, and the VLAN isolation for IoT versus corporate. And there we go. We have successfully built, you and I, well, I show you how I did it, but you and I, we have successfully built an enterprise-grade, scalable, and secure network that supports real-time automation, remote operations, voice and sensors, and public web access, while maintaining segmentation, efficiency, and strong protection. Thank you for listening and watching my instructions, and hope this helps you.